Good day, dear participants. We offer you a report on the topic Specialized Interactive Methods for Using Data on Radar Application Models. The authors of the research, AndriiVasyliuk, Basyuk, Vasyl, Lytvyn. Every day, humanity is confronted with some data. This can be a variety of news, statistics, research findings, and more. But most of what individuals are confronted with is the inability to extract the necessary information from the continuous stream of everything that surrounds them. An important problem today is the structuring of information, the ability to see or find the data needed at a particular point of time and be able to use it for the right purposes. In order to manage the large-scale information that is used daily in various spheres of human life effectively, there is a need for the structuring, filtering, and visual presentation. Information graphics has gained important status in many areas of our lives, including political, educational, etc. Of great importance was this visualization of data in air traffic systems, namely the display of the location of both existing and potential radars on the terrain map. Important aspects of information visualization are interactivity and dynamics of visual representation. Existing methods allow the user to modify the model in real time, thereby enabling its perceptions based on abstract data. Visualization uses interactive visual representations of data to increase cognition. This means that the data is converted in an image that is displayed on the operator screen. In this case, the image can be changed, and this interaction is important as it allows for permanent definition of goals. Since the inception of the information visualization field, many researchers are still working on the topic, looking for new methods and improving the results of their precursors. One of them is the famous American scientist Stuart C. Card. He was a senior scientist of Xerox PAC and one of the founders of the human factor in human-computer interaction. His research is devoted to the fields of development and support of human interaction, information, and visual semantic prototypes for the purpose of their greater understanding. As can be seen from the analysis, this area is extremely important, but has not been fully studied yet. Given that the actual task is to create a system for displaying existing radars and area they cover and identify location for the installation of new objects to cover the entire territory. The purpose of the study is to create a system of interactive data visualization on example of radar models. The study will provide a means of displaying existing radars, displaying their technical status and characteristics, and providing guidance of the optimal location of new objects. To achieve this goal, it is necessary to solve the following main tasks: to analyze the existing scientific research and approaches used in the field of interactive visualizations to identify the main tasks that arise, to build models according to which the process of data visualization can be carried out, and to implement the proposed approach in the software. The results of study solve the urgent task of creating a mathematical software for the process of displaying existing radars and identifying places for the installation of new objects to cover the entire territory. The conducted analysis showed that for today the following basic patterns: visualizations of information are used: maps, geographical maps, infographic maps, cartograms. Linear time graphs used to visualize temporal information such as Gantt charts. Networks used to visualize dependencies, relationships, and hierarchies. A classic example of the use of linear time graphs is the image shown in figure. This is a graph of Colton trains departure times shown on the x-axis, stations on the y-axis. This visualization meets the standards of good visualizations. It can be seen from figure that the stations are separated in proportion to the distance between them. The slope of the lines reflects the real speed of the train. The steeper in the line, the faster the train. However, this view has limitations in terms of user interaction at the data filtering level. Taking into account the peculiarities, the algebra of algorithm was chosen to create models of the design system, by means of which it's possible to perform synthesis and minimization of mathematical models. Okay, taking into account the peculiarities, the algebra algorithm was chosen to create models of the design system, by means of which possible to perform synthesis of mathematical models. First stage of synthesis is the synthesis of uniterms, sequences, and eliminations. In this system we had such terms like read-reader data, RD, construction of a reader placement model, overlaying the model on a map using mapping services, visualization of result without taking into account the technical characteristic of the readers. It has been seen on this slide. Okay, next slide. The model will contain the following sequences. First sequence is S1, and this is a sequence of description of results with visualization in the presence of radar specifications. And sequence 2, it's a sequence of description of result visualization in the absence of radar specifications. Next slide is synthesis of eliminations. After substituting sequences S1 and S2, for eliminations we get the following model. Using the properties of signs of operations of formulas in the algebra algorithms, we derive the uniterms RD, BM, OM, QT, V1, V1R, and V2R for the sign of the eliminations operation L1. The operation of the project system can be represented in the form of a model, sequence S3, which describes the visualization of data on the example of radar systems. After the models were built, well-known map rendering tools were analyzed. The most famous resource is Google Maps, which is a suite of applications built on the free mapping service and technology provided by Google. The Google Static Maps API lets you build static maps using custom URLs. There are also API version for different types of the mobile devices. OpenStreetMap is an open source project to create public world maps by community forces. The OpenStreetMap resource provides a sliding map interface based on JavaScript from the MoMLeT library, which displays the map in real time using tiles generated by Mapnik and tiles from other sources. You can generate maps locally by installing Mapnik and downloading data. The JetBrains WebStorm environment was chosen to develop the online resource. The main window of the system with placed radars on the figure. The radars is shown in figure. To display the technical status of the radar, their icons are colored in different colors. Working radars are also complemented by animated cycles. In the left corner of the window, use a menu and scroll bar with the ability to zoom the map and change position. A graphical representation of the radars or radar action is shown in figure. Each radar has its own info window which contains detailed technical information. To open it, it is necessary to click on the appropriate radar citation. It is also possible to view the radar range and the invisible radar area for the radar. The system had the function of determining of the optimal location for the placement of new radars to fill all the invisible areas. The proposed radars are displayed on the map in green as shown in figure. If necessary, the user can change the appearance of the map and turn off the labels to indicate geographical units. Okay, conclusion. As a result of the conducted research, the existing technologies and methods of data visualization that are used in the process of data display are analyzed, and the main tasks that arise are shown. In accordance with the algorithm algebra, domain modeling was performed, which made it possible to synthesize and minimize a mathematical model of data visualization on the example of radar station models. The proposed approaches were used in the process of implementing the task using JavaScript in the JetBeans WebStorm environment. Further research will direct it towards the creation of related software modeling, models, their verification and harmonization of functioning.